On the back of my phone, this looks like a harmless MagSafe wallet. But the moment I snap it off, it wakes up. Today, I'm building a MagSafe accessory that transforms from a card holder into a high voltage plasma lighter. For the plasma arc, I first bought this cheap HV1 module. It's ready to use solution, which made a good starting point. But while testing it, I realized that the arc is very weak. So the transformer wires have to be extremely close to each other. Another issue is heat. The transistor gets incredibly hot after just a few seconds of use. So clearly the easy way doesn't always work. So we need to find a way to improve it. The HV1 is a single transistor flyback driver. It's famous for being simple, but it has a major flaw. It uses a BJT transistor that wastes a lot of power as a heat instead of producing a strong high voltage arc. To upgrade it, we swapped the transistor for power MOSFET. For this, I choose the IRF540 MOSFET because it's low on resistance, minimize power losses heat, and its drain to source voltage rating is high enough to handle the inductive spikes from the transformer. To improve reliability, I redesigned the driver. I added a 12V Zener diode to clamp the voltage spikes. This 330 ohm resistor in the feedback loop stabilizes the oscillation and limits current. Finally, a 10K pull-down resistor prevents false triggering and keeps the MOSFET gate stable. That was the theory. Now let's test it in real life. As you can see, the plasma arc is much stronger now. We can even increase the distance between the transformer wires and still maintain the arc. And just as we predicted, the MOSFET doesn't get hot. Now we need a battery to power the circuit. Before that, I want to introduce this video's sponsor, JLC PCB. Let's take a look at their flexible PCBs. If you're designing compact DIY electronics, you probably know that ultra-compact spaces heavily restricted routing freedom, and traditional adhesive PI films can easily blister under soldering heat. That's why their custom flexible PCBs are built to bend, built to last. With JLC PCB's precision LDI technology and adhesive-less PI film, you get enhanced FPC reliable and thermal performance for demanding applications. Their starting price is just $2 for 5 pieces. Grab a $10 coupon for your first flexible PCB order. Just check the link in the video description to claim our coupon and upgrade your next project. To power the lighter, I'm using a small 350 mAh high power LiPo battery. It's a 25C1, so we can draw up to 8 amps from it. I also got this TP4056 module to safely charge the battery. I picked this one with an internal BMS since my battery doesn't have one built in. So after we picked all the electronic parts we needed, I spent several hours designing this MagSafe case to fit everything neatly. I wanted the lighter to stay hidden, so I added this slide mechanism here. It also keeps the lighter safer. Most of the case parts are 3D printed. You can download the files using the link in the description. Now comes the tricky part, assembly. All of these components have to fit inside the MagSafe card holder. If you enjoyed the video, drop a like and subscribe for more builds like this. This 3D printed slide mechanism holds the transformer in place. A spring is added so it automatically slides back after being pushed. Once it's placed on the bottom body, this knob locks everything in position. Now that we are done with the slide mechanism, trim the transformer secondary wires to 11mm and bend the tips of the wires to create a 7mm gap. As you can see, when the knob is pushed forward, the mechanism slides out and press the key. When released, it returns to its initial position and turns the circuit off. Okay, let's finish soldering the rest of the components. The lighter side is completed. Now we can test it. It works, but there is a weird problem. It fires for a second and then dies. It looks like something is wrong with the switch, so it's better to take a closer look at its performance. It seems that the slide mechanism presses the switch fully, but the plus mark still cuts out after a second. So there is no problem with the switch. Now I can say the TP4056 BMS circuit is the problem. It can't supply enough current for the lighter, so it shuts off the circuit. Since I don't want to change my design, I'm hoping I can boost this TP4056. It seems that the protection chip uses the resistance of this MOSFET to sense current. If we solder another 8205A MOSFET directly on top, we put them in parallel, which cuts the electrical resistance in half, allowing us to draw more current. Let's put it back together and see if this trick works. That fixes it. The BMS circuit no longer cuts the power. The lighter is done, now onto the card holder. I wanted it to look stylish, so I'm going to cover the top part with leather. Since I can't really freehand it, I printed this template to make sure the cut is accurate. We still need to trim the edges, but first let's apply some glue to the top part and stick the leather onto it. Now that it's glued down, I'll cut these two thin slots and fold the leather over the edges to give it a clean finish and make it easier to slide the card into the holder. I'm going to attach this piece of foam to the back of the top part. It helps the card fit snugly inside the holder. Now we can attach it to the main body. But first we need to place this inner part inside. It has a ring that fits into the main body and keeps it in place. I applied some glue around the edges to securely hold the top part on the card holder. The last part to attach is the MagSafe magnet array. If you want to learn how the MagSafe system works and build your own MagSafe power bank, be sure to check out the video in the top right corner. It's also linked in the description. As I mentioned earlier, you can also find all the design files there. With that, our card holder is ready. Now your MagSafe card holder doesn't just store your cards, it also hides a plasma lighter inside. If you have any questions, leave a comment down below. Don't forget to subscribe for more DIY builds. Thanks for watching and see you in the next one.